yesterday we talked about the law of sines. And we had that ratio, side A over sine of angle A equals side B over sine angle B equals side C over sine angle C. And I told you you could take any two at a time and set up the proportion to solve. Now, the problems we were doing yesterday, on all of those, I gave you two angles and one side. Did you guys notice that?
Yep.
And you always found your third angle just by subtracting from 180. But if I gave you two sides and one angle, you wouldn't be able to find your missing angle just from subtracting from 180. So we have to keep looking at this law of sines. Now, the issue comes in that when I give you only one angle, you will be solving something like whatever side A, let's say 5.6 over sine of A equals 6.8 over sine of 73 degrees. You'll be solving something like that. When you solve this, so you'll get sine A equals some number. How do you solve for a missing angle? You have to do sine inverse. Now, we know that in a triangle your angles add up to 180. So your answer could really be anything between 0 and 180. You agree with that? Sine inverse, you get a number. Sine is positive in which quadrants? 1 and 2. Isn't every angle in quadrant 1 and 2 between 0 and 180? Yes. So what happens on these is when you set this up and solve it, you will actually get two different answers for your A. One in quadrant 1 and one in quadrant 2. And we have to decide, are both of those answers possible? Is neither one of them possible? Or does only one work? So in these problems, if I give you two sides and only one angle, it's possible that there is no solution to the problem. It's possible that there's one solution and it's possible to get two solutions. So we will have to look problem by problem and figure out what our solutions are. Now if you look in the book, it goes into a lot of detail about all your possibilities and what creates each of these possibilities, and gives you this lovely table that you could look at and tells you, if an angle is bigger than 1, if it's equal to 1, if it's between 0 and 1, and it tells you all these options. I think it's easiest just to completely ignore all of the rules the book gives you and just work the problem and use our common sense to decide if the answer works or not. So if you guys are okay with that, I'm sure you're going to go home and read the book and wonder why I didn't teach you all those rules. But if we're just trying to understand it, let's just use our common sense, use what we know, and not worry about being able to look at the problem and figuring out how many solutions it has. Just work it and figure out how many solutions we get. Does that sound fair to everybody? Okay, so we're going to ignore all of this, and we're just going to jump right in with an example. So if I were to draw a picture, and of course my picture is not to scale. We have triangle A, B, C. Side A, so that's across from angle A, is 17.9. Side C, so across from angle C, is 13.2. And angle C is 75 degrees, 30 minutes. Can I do Pythagorean theorem to get my missing side? No. Why? Pythagorean theorem only works if it's a right triangle. This isn't a right triangle, so we can't do that. Now, we're going to use our law of sines. Which two ratios should we be using here? C and A. Those are the two we have information about. So A over sine A equals c over sine c. So side A was 17.9 over sine of angle A equals side C, 13.2 over the sine of 75 degrees, 30 minutes. Okay, if I asked you to solve this, we would have to multiply over our denominator. If you multiply over sine A, then we're going to have to divide over this big fraction. So what you are actually going to type in your calculator is 17.9 divided by, big parenthesis, 13.2 divided by sine 75 degrees, 30 minutes, so you do 75 plus 30 over 60. Make sure you are in which mode? Degree mode. So this tells me that sine A equals, what did you guys get? .2615? Did you guys get that? I wrote down 17.2 instead of 17.9. How about 1.3129? Is that better? Okay. That's a positive. Sine is positive in which quadrants? 1 and 2. So you would have to get an answer for both of those. If you do sine inverse, so second sine, 1.3129. What do you get? Error. Why? What values can sine equal? What kind of numbers do you get? Something less than 1, right? Between -1 and +1. Think about your unit circle. Can sine equal a 1.3? No, never. So we didn't memorize the rules. We didn't know from the original problem that it wasn't going to work, but I got something that I could not solve, so I know right now there's no solution. There is not a triangle that meets these conditions. Now, something I want to point out. It was a little annoying trying to solve this because you had to multiply your sine and divide by that big expression. It's certainly something we can handle, but yesterday, the rule I gave you, the law of sines, was A over sine A equals B over sine B equals C over sine C. The reciprocal is also true. So sine A over A equals sine B over B equals sine C over C. You can set it up either way, but on that problem, if we had flipped it and put the thing we didn't know on top, all we'd have to do is multiply our denominator over and plug it in our calculator. So the easiest option when you're setting these up is to put your unknown on the numerator. So it'll either be the sines on the top or the side lengths, just depending on what you need to find. If you want to find an angle, make your sines on top. If you want to find a side, make your side lengths on top. And that, if you flip them, it's not a big deal. We can still solve it, but this will just make your problem a little bit nicer along the way. Okay. Questions there? going to jump around a bit. So I want to do, we're going to do this one next. All right. Triangle ABC, angle A is 61.4 degrees, side A is 35.5, side B is 39.2. What should we find first here? Angle B. So since I want to find an angle, let's put our signs on top. We have information about A, so we are going to do sine A over A equals sine B over B. So that would be sine of 61.4 degrees over 35.5 equals the sine of B over 39.2. So then we have to multiply over our 39.2, and we're just going to put that in our calculator. So 39.2 times sine of 61.4 over 35.5. You want to keep quite a few decimal places on this. If you round this to just 2 or 3 decimal places, when you find your angle, you will be slightly off. So keep more decimal places here. For my final answer, how many significant digits will I use? 3. Okay, so we know that sine is positive in quadrants 1 and 2. So I am going to get an answer in each of those. So what do we need to do first? So we're going to do sine inverse of 0.96949. That will give me my reference angle. And so we get B to equal 75.8 degrees. I'm going to 3 significant digits. Is that the only possible answer? No. That's the first possibility. Or, if you are in the second quadrant, what would you have to do to that? Subtract from 180. So 180 minus 75.8 gives me 104.2 degrees. So right now we have 2 different triangles. I'm just going to call them triangle 1 and triangle 2. Okay, so we know it's not no solution. We got that on the first problem. This one we have 2. Right now we need to check to make sure this is possible. So let's find our third angle. If you have 2 angles, how do you get the third? Subtract from 180. So I need to do 180 minus 75.8 minus my original angle A was 61.4. We get 42.8 degrees. And triangle 2, 180 minus 104.2 minus 61.4 gives me 14.4 degrees. Since right now I have 3 angles, they're all positive, I have 2 solutions. You need to make sure that you are organizing all of your information for triangle 1 versus your information for triangle 2. Okay, so the original problem I gave you side A, side B, and angle A. We now know the rest of our angles, but we need to find our third side, which is side C. So to do that, we are going to do the law of sines again. Since I'm looking for side C, let's set it up where the side is on top. So you could technically use A or B for the rest of it. I prefer to use the numbers they gave me in the problem, so I'm going to go back and use my A's. So side A was 35.5 over sine of angle A, which was 61.4, equals side, which side am I looking for here? C, over sine of C, and we found angle C to be 42.8 degrees. So this is like yesterday's problems. Take it times the sine of 42.8. And we get that side C is 3 significant digits, so 27.5 centimeters. So here's my triangle 1 information. Triangle 2, we're going to set up the same way. Side A over sine of A equals side C over the sine, but this time my angle C is 14.4 degrees. And I get my side C to equal 10.1 centimeters. You should do just a quick check at the end to make sure your answers are reasonable. Remember, in a triangle, the biggest side has to be across from the biggest angle, and the smallest side is across from the smallest angle. So if we did a quick check in triangle 1, angle B was the biggest. Is side B my biggest side? Yeah. Angle C was the smallest. Is angle C my smallest side? Yeah. Okay, same thing in triangle 2. Angle B is the biggest angle, and angle B turned out to be the biggest side. C was the smallest angle, so side C is the smallest side. That's just a quick check you can do at the end to make sure that you didn't make a mistake somewhere along the way. Biggest angle and biggest side always match up. Same for the smallest angle and smallest side. Alright, any questions on that? Let's look at another one. So if we start setting this up, angle B is 68.7 degrees, side B is 25.4, side A is 19.6. So first we need to find angle A. So let's do, since I'm looking for the angle, let's do sine A over A equals sine B over B. So the sine of angle A over 19.6 equals the sine So now we have to find our two triangles. So we're going to do sine inverse of that. So in triangle 1, we go to 3 significant digits. That would take it to 46.0 degrees. In triangle 2, what do we have to do? 180 minus 46, which gives me 134 degrees. Okay, next step, find angle C. So 180 minus 46 minus angle B, which was 68.7. That gives me 65.3 degrees. Over here, 180 minus 134 minus 68.7 gives me negative 22.7 degrees. What does that mean? Can't happen. You can't have a triangle with a negative angle. So this is a case where we are only getting one triangle. Okay, so now all I have left to do is find side C. So we will go back and set up. We had all the information for B. Since I'm looking for a side, I'll put my sides on top. So that would be 25.4 over the sine of 68.7 equals C over sine 65.3. Divided 24.8 inches for my side.
Could you have used A?
Yes. So it's okay? You guys want to try some on your own now? Why don't you guys do this? So we're looking for an angle, angle A, so we would do sine A over 25.1 equals sine 55 degrees, 40 minutes over 8.94. When you plug that all in, you get sine A to equal 2.3184. So when you solve that, what happens? No solution. Sine can't be bigger than a negative, or bigger than 1. So no triangle exists on that one. Alright, let's do this one together. So I gave you angle A and side A and side B. So what angle am I looking for first? B. So I could do sine B over side B equals sine A over side A. have to do sine inverse. And I get angle B to equal 63.9 degrees for triangle 1. What do you do for triangle 2? 180 minus 63.9 gives me 116.1 degrees. So at this point, we're either going to have one or two triangles. We're going to find angle C to determine which case it is. So you do 180 minus angle B minus angle A. And we get 60.8 degrees. And the second one I get 8.6 degrees. Is that reasonable? Yeah, it's a pretty small angle, but it's positive, so it's okay. We know that in both of these scenarios, angle B is the biggest, so side B is going to be our biggest side. In the first one, angle A is the smallest, so angle A, or side A will be the smallest side. And the second triangle C will be the smallest. So now we need to find side C. So we could do C over the sine of C equals, I'm going to do A. Side A is 22.8 over the sine of A. So for the first triangle, my side is 24.2. Does that seem reasonable? Side B is the biggest. Side A is the smallest. Angle B is the biggest. Angle A is the smallest. So that one all worked out. Second one, set it up. And this one I get 4.15. Do you guys have questions for me? Do you need additional?
So like having a certain amount of numbers, let's say you only have 2 or you only have 3, is that not apply to this?
You mean significant digits?
Yeah.
Yeah, that I probably should. I didn't do it on this problem, but probably should have. Any other questions? Do we need more problems? So I'm gonna stop here. I'm actually, this is kinda crazy, never happens, but I'm going to give you guys a work day tomorrow, and it's not a very long assignment, so you might get done and have extra time in class. The other thing that I need you guys to do, we have to do MACC evaluations if you're taking this class for college credit. So do you wanna do that today or tomorrow? You guys have a preference? Oh gosh, you're 46. You wanna do that tomorrow for those of you taking them? So we'll do that tomorrow, and then the rest